Okay, welcome back, class. Part 3 is about identifying different types of graphs. So not functions. Functions was part 2. So these won't be functions. This is about identifying and reading how to read questions from different types of graphs. So the first graph we have here is a line graph. I think you've all seen a line graph before, but it makes a line. So normally a line, it's over something. Line graphs are used to display continuous data. Normally that means time, so something over time, but it doesn't have to be time. It's just any data that is continuous. It's just most often that is time. Line graphs can be useful in predicting future events when they show trends over time. And the way we read a line graph, it's just like reading any of our other graphs. This one's pretty easy. So number one, way we read it, we've got the time on bottom, or our continuous data for our horizontal axis, and then we've got some other piece, in this case, the number of customers in the store. So this is customers in the store over the time of day. So number one here asks how many customers were in the store at 1 p.m. Well, we can go to 1 p.m. and then here's 1 p.m. and then go up until we hit our graph. And our point there, our graph crosses 1 p.m. right here, and then so 1 p.m., and then that point has a value of 70 customers in the store. So suspect everybody's read one of these before, but 70 customers in the store. How many customers were in the store the last 2 hours of the day? Well, we can do that by summing up. Well, the last 2 hours are 7 p.m. and 6 p.m. and we can sum those up or by adding these values. So there was roughly 40 at 6 p.m. and then at 7 p.m. there was roughly 38. So over the last 2 hours we can add those. There's roughly 40 at 6 p.m. Roughly, I would say, it's close to like 36, I guess. It's about halfway, just our best guess. Plus about 36 at 7, so that adds up to 76. So there's roughly 76 customers. And then number 3, how many more customers were in the store at 3 than at 11? Well, at 3, there was 50. And at 11 a.m. there was 30. So how many more? Well, to find how many more of something, we subtract. So 50 minus 30 is 20. So there were 20 more customers in the store at 3 than at 11. Okay. If you have any questions on these, please ask the sub or ask me when we return. So we'll be given some very basic info to read from these. The next one is a bar graph. Bar graphs are used to display categories of data. A bar graph is one method of comparing, and we compare by using solid bars to represent unique quantities. It's only one method of comparing. So here we're asked, what can I learn by looking at this bar graph? Well, this is textbooks down here, and we've got different subjects. And then it's the number of pages in that textbook. So what can we learn? The number of pages per textbook for each subject, really, but we'll shorten that to per textbook. And then we're asked for number 2, how many more pages are in the math book than the health book? Well, the math book, we come over to math and we look here, and this is about a quarter of the way up. So we could say it's about 650 because this graph goes by 200. So about 650. And we just did a more problem. How many more means we'll subtract the number of pages in the health book. And the health book is about an eighth of the way up. So 400 and I would estimate about 25. So 650 minus 425 is going to give us 225. So there's roughly 225 more pages in the math textbook than in the health textbook. Excuse me. Next is a histogram. A histogram is a special type of bar graph that we use to represent frequency of numerical data that has been organized into intervals. So because the intervals are all equal, all the bars will have the same width. And you can see here they all have the same width and they're touching. The intervals are continuous, so there's no space between the bars. That's why they're touching. So sometimes we can use it for overtime, but line graphs usually used for that. But here we have intervals. We have total pages in books. So we've got between 0 and 200, between 200 and 400, or 399, between 400 and 599 pages, 600 to 799. So you get the idea. It's books that have within this amount of pages. And the first one we're asked is, how many textbooks have between 200 and 599 pages? Well, 200's here, but 599 is there. So we're actually looking for two intervals. So we want to add these up. Well, roughly 20 books have pages 200 to 399, and then another 40 have pages between 400 and 599. So this is 20 plus 40. So this number is roughly 60 books. And then we're asked there are 30 textbooks that have how many pages? So for that, we can come over here to 30 and find the one that matches. Well, the one that matches is this one. And this one is 600 to 799 pages. So within this 200 page interval, there's 30 textbooks that have roughly 600 to 799 pages. Okay, I'll be back in just a moment. Apologize. One of these has one that's not on there, and I'm trying to remember which one it is. It's the last two. Okay, I apologize for that. The next one here is a frequency table. Frequency tables show the number of pieces of data that fall within given intervals. So they're sort of similar to a histogram, except we mark these with tallies instead. So what does this table tell me? Well, this is talking about the rulers of England, and it says they range for 1 to 15 years, 16 to 30, all the way up to 60 to 71. So this is telling us, well, how many rulers reigned within that many span of years. So it's telling us how long English, or well, how many, I guess would be better, how many rulers reigned within that span of years for that many years. So it gets a little cramped here, years. So roughly we can look, our frequency is 18 between 1 to 15. So that means there were 18 rulers of England that reigned between 1 and 15 years. 16 to 30 has 11. So that means there was 11 rulers that reigned between 16 and 30 years. Believe it or not, this chart is actually correct, except it's not fully up to date because it does not count Queen Elizabeth II dying. So, and she died a couple of years ago. So it does not have her son, King Charles, I believe. Or is it King Philip? I can't remember which one. Anyways, it's not important. How many rulers reigned for more than 45 years? Well, we've got 4. So 40, more than 45 is 46 or more. Well, we've got 4 reigning for 46 to 60 years, and we've got 1 reigning for even longer than that, which that would be Queen Elizabeth. So we've got 4 plus 1, which equals 5. There were 5 rulers that reigned for more than 45 years. So this one would be Queen Elizabeth herself. So, because she reigned the longest. How many rulers has England had? Well, to find that, that's just the total amount of data. So we can just add all of these up. So 18 plus 11 is 29. Yeah, 29 plus 6 is 35. Plus 4 is 39. Plus 1 is 40. So we can add all of those up. So 18 plus 11 plus 6 plus 4 plus 1, and that should equal 40. I'm going to double check on my calculator real quick. 18 plus 11 plus 6 plus 4 plus 1 is 40. Okay, so I was right. So England has had 40 rulers up to when Queen Elizabeth was still ruling. And then the last question here, create a question that can be answered by looking at this frequency table. Well, there's several. You could ask something like, how many rulers reign for less than 30 years? So let's go with that one. How many rulers reigned for less than 30 years? And the answer to that would be 11 plus 18, so 29. But there's several questions we could ask. You could ask, well, how many rulers reigned between 16 and 60 years? Or how many rulers reigned less than 60 years but more than 30 years? So there's all types of questions we can ask. So if you have any questions on any of these, please ask your sub. If you need to, she can pause it. All of these tables will be completely filled out on, all of these graphs will be completely filled out on Google Classroom, though, so you can copy them from there. Next is a line plot. A line plot is a diagram that shows the frequency of data on a number line. So an X is placed above a number each time that specific data value occurs. Numbers that are quite separated from the rest of the range are called outliers. And in a line plot, we can easily find the range of the data, which is the difference between the greatest and least numbers in the data set. So this one will be on for a little bit. So here we've got an X above 62. That means that 62 occurred once in this set of data. Here above 28, we've got 2 X's. That means 28 occurred twice in this set of data. So, and it says which number of stories occurred the most often. So I assume they're going with something like the stories in a building. So there was 2 buildings in this survey that had 28 stories. And there was one that had 73 stories. So whatever survey this is. First of all, we've got a couple of vocab words. The range is the difference between the greatest and least numbers in the data set. That means the greatest and least that occurred, not the greatest and least that actually appear on the table. And we'll talk about that in a moment. And the outliers occur in any type of table, but they are numbers that are not close to the rest of the data. They're very far removed. And then, so let's answer these questions, and we're actually going to add 2 more here. The first question is, which number of stories occurred the most often? Something that occurs the most often, sorry, I was looking there. Something that occurs the most often is called the mode. So most often means the mode, which you might have heard all of these vocab words before, but something that occurs the most often is the mode. Well, the one that occurs the most often is the one with the most number of x's, and we can visually see that it's 52 with 1, 2, 3, 4, 5 x's. So 52 is occurred the most often, so that is our mode. What are the 2 outliers on this set of data? So the 2 points that are farthest from the data, there's usually means a minimum and a maximum outlier, but they don't have to be. But the 2 outliers are this one here. That occurred very far away. That one is 17. And this one that occurred really far away is 72. No, 73. Sorry. That one is 73. So those are our 2 outliers. So outlier here, outlier there, the ones that occurred very far away from the range. While we're on that outlier, or well, actually, they'll come next. What is the range of this set of data? Remember, that's the difference between the greatest and least numbers in the data set. This data set goes from 50 to 75. However, 15, and 75 do not actually occur in this data. So we do not count those. It is not what is visible. It is the ones that actually occur. Well, the smallest number that actually occurs in this set of data was this one, 17. The smallest number is the one we call the minimum. So you might remember that. The minimum is the smallest number. And the greatest number that actually occurred in this set is 73. And the minimum, or the greatest number, is the one we call the maximum. And you might remember that. So the range is really the maximum, or short for max, minus the minimum. So max minus the minimum. Max minus min. Maximum minus the minimum. Max minus min. Which that is 73 minus 17. 73 minus 17 is 58, I think. 73 minus 17, 56. I don't know. 56. So our range is 56. In this one, we're going to add 2 more questions. The next question, and let me look it up. I can't. Sorry, I'll be back in a moment. I cannot remember what the question is. The next one is the average. So what is the average the average of this data. The average is also known as the mean. So the mean is the average. And there's a few types of means, but for us, that means the number. It means the total amount or total data. So sum of the data. So sum of the data means we're adding all the data up divided by the amount of data, which means then we're counting how many x's actually occurred. So we add all the values up, so 17 plus 28 plus 28 plus 31 plus 32, we add all of that up, and then we divide by the number of x's itself, so the amount of data. So 1, 2, 3, 4, 5, and the mean, and I've got this wrote down, I apologize, it's okay, I don't have it completely wrote down. 1, 2, 3, 4, 5. So, okay, I don't have it wrote down. I thought I did. Okay, so let's find the sum of the data. That's 17. I'll find it real quick. 17 plus, and there's a lot of numbers to add. 17 plus 28 plus 28 plus 31 plus 32 plus 33 plus 33 plus 34 plus 34 plus 34 plus 36 plus 36 again plus 37 plus 39 plus 40 plus 41 plus 42 plus 42 again plus 44 three times, so 44 plus 44 plus 44 plus 48 plus 52 five times, 52 plus 52 plus 52 plus 52 plus 52 plus 53 plus 54 plus 55, so that's there, plus 62, and then plus 73. So I get that the sum of the data is 1354. So if you add all those numbers up, I get 1354. And we have the amount of data is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. I counted 32 x's. So I get the sum of the data is 1354. The amount of data is 32. So 1354 divided by 32 is 42.3 roughly. So the average, excuse me, the average or the mean of this data is 42.3. So that one's a longer one, harder one, and I've got one more here. The last question is what number is in the middle? So what number occurs in the middle is also known as the median. And it is a bit easier to find. We do not count the numbers that don't actually occur. So it's the middle that actually occurs. And the way we find it is actually relatively straightforward. We want the middle one, so we're going to cross off the lowest one and the highest one. And then we cross off the next lowest x, and then the next highest x. And we will keep repeating this until there's only 1 or 2 left. So the next lowest, next highest, 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 so on and so forth. So boom, 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 there, 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 and now we've got 2 of them left. So if there was only 1 left, if we crossed off a low and high and we were left with exactly 1x left, then that specific number would be our median. Now, because there are 2, well, you can probably guess, we're just going to split the difference. So this one was 41. Excuse me. This x was 41. This x was 42. And so because there was 2, we're just going to say the middle is halfway between there. So the middle would be 41.5. Okay. And I know that's a long one, and I went through it relatively quick. Once again, if you have any questions, please ask. Okay. Our next type is a stem and leaf plot. In a stem and leaf plot, data is organized from smallest to greatest. The digits of the last place form the leaves, and then the next place form the stems. And it actually has a guide on how we read this right here. So this piece here is our tens place, and then this piece here is our ones place for our digit. So this number here, 3 and 1, would be 31. And I'm not sure what we're counting. It's something in years here. But we're asked, number 1, what's the smallest number? Remember, the smallest number is our minimum. So this is asking what the minimum is. Well, the smallest number, because this is all organized from least to greatest, the smallest number is the first number that occurred. So this is our tens place for that number. This is our ones place. So, and this reads 2, 6. So 26. What is the largest number that occurs or that's represented? Remember, the largest is the maximum. Well, that's just the last number because this is all organized from least to greatest. So the last number is 70 or 70. So 70. And then weirdly, this third one lists 3 more numbers that can be found on the stem and leaf plot. I mean, you could list any 3. Let's just go with, I can find 42. 42 is right there. I can find 33 right there. 33. And I can find 65. Gotcha. I knew you were thinking it. 65 right there. I cannot find 67 on this graph. So it did not occur. So honestly, the hardest part of this is reading it. But if you had to average or you had to find the median, you do the same thing as the last one. But this one's just kind of goofy to read. Our next one is a circle graph, or better known as a pie chart. Circle graphs are used to show a relationship of the parts to a whole. So it's used to show something out of a whole. So it's a percentage, usually, basically. Because of this, percentages are used to show how much of the whole category, how each category represents. So the percentages will always add up to 100, or they should. And then here we're asked a few questions. What percent of students attend college? Well, that's 15%. If we knew how many total we were talking about, well then say it was 100, say it's 100, well then that means 15 students attended college. If it's 200, that'd be 30 students, but we don't know the actual numbers. We only know the percent here. Which three groups combined make up nearly the same percent as grades 1 through 8? Well, grades 1 through 8 make up 45%. So we want three groups combined that make up close to 45%. So let's see, 22. I think it's grades. I've got it wrote down. Let me double check. I think it's grades 9 through 12, college and other. Let me double check. Yes, it is. Grades 9 through 12, college and other. So great. If we add 9 through 12 up, so 9 through 12, college, other. If we add those up, then we've got 6 plus 15 plus 22%, which equals 43%. And then the next closest would be and swap other for kindergarten, and that gives us 49%. What students attend K through 8? Well, 1 through 8. K stands for kindergarten. So kindergarten through 8th grade, all we have to do is add those. So 12 plus 45 equals 57%. So 57% of students attended kindergarten through 8th grade. And then lastly, what could the group of other be made up of? Well, other could be like homeschool, but it says grade level of U.S. students, so they don't really have it. It could be like something like homeschool because they're not really attending kindergarten through 8th grade. It could be like military school or prep school. So military school. Or we've got college here, but it could be something like a trade school, like a welding school. So I'll put that one as well. So trade school. I mean, that's a bit different than college, so maybe they were defining it differently. So it could be something like that. I think this one and the line graph are the two that you guys know how to read already. Okay, and then the last one. The last one we'll talk about is a box and whiskers plot. And a box and whiskers is kind of goofy. A box and whiskers plot is a diagram that summarizes data by dividing it into 4 parts, which we call quartiles. So quarter, 4. Box and whiskers show us the spread, which is another name for the range, and the median, which is the middle piece of the data, which we talked about. So what is the range of this data? Well, the highest number that occurred was 90, and the lowest number that occurred was 20, so the range is 70. The median of this, so this is the max, so max, min. The median is really easy to find because it is this middle line that splits our box here, or for the box and whisker. So this is a whisker, that's a box, hence box and whiskers. The median is the number that splits our middle line. So that number is 50. So the way this works is this first whisker represents a quarter of our data occurred here. This first box represents another quarter of our data. So 25% and then 25 through 50%. And then this second box represents 50 through 75. And then the last whisker is another 25, so 75 through 100. So this could be something like grades, and it could be like, oh, a quarter of the kids got grades here, a quarter of the kids got grades here, a quarter of the kids got grades here on the test, and a quarter of them scored within this range. And actually, that's the most common I've seen it. I can pull up a box and whiskers of you guys' grades on Infinite Campus if I want. For can't remember if it does it by assignment or I think it's just per student. So like your average, so like a quarter of your points. So like a quarter of the time your grade was a 20%, which is really bad, and then a quarter of it's between 60 and 90. But anyways, but because of this is a quarter, this is a quarter, that's a quarter, that's a quarter. Well, then that makes 1/2, and this makes 1/2. So that's our median. So that is 50. The minimum value in this data set, well, we already needed that to find our range. That was 20. So, and I already marked it. And then I think there was one more question here that I had. Nope, there's two. But that's very easy. The two other questions. The fourth one is, what is the maximum? Well, that's easy. I already marked it. It was 90. So we needed the max minus the min for our range here. And then the last one is, what is the fourth quartile? And that one means, where does the fourth, and I'm actually going to throw another one in here in a moment. So what is the fourth quartile means, where does the fourth quartile start? So for the fourth quartile, it starts right here. So remember, the last whisker is the start of the last quarter of data. So it starts, or that is the last quarter of data. So it starts at 60. So then this is 60. And I'm going to throw one more here. What is the first quartile? And this one's kind of weird, because for the first quartile, it means, where does the first one end? So where does the second one start? Well, the first one ends at 30. So this one is 30. So, or that would be the second quartile. So, but actually, I can't remember if that's correct or not. I think so. I'm going to leave that in. I'm confident that's correct. I don't use quartiles a lot, so forgive me. But you might run into one of those questions on your assignment. So that's why I'm doing it. So you can go with that. Where does it begin? For the first one, where does it end? Let me double check. I think that is everything here for part 3. Let me double check real quick in case I missed anything. That is everything. So because that is everything, we've covered parts 2 and part 3 today. If you have any questions, please ask the sub, or please ask me when I return. Otherwise, you have assignments for both of these parts. They will both be on Delta Math. I do not need you to show me your work for either one of them. So there you go. There's a little treat for you. So I don't need the work for either one of them, but you do have a part 2 assignment and you do have a part 3 assignment. Those two will be due it's Friday the 26th when I'm recording this. Let's see. You will get this on Monday the 29th. Those two will be due Wednesday the 8th. So Wednesday the 8th. So you have well over a week to do them, so plenty of time. Okay. Otherwise, that's it, and I'll see you when I return.